Okay, so the next graph we're going to sketch is the cubic graph, and you should be familiar with this from GCSE. So I'm just going to sketch this for you. It's quite a difficult one to sketch accurately, but its general shape is somewhat like this. So remember, this is a sketch, and normally you wouldn't have values on the axis, but I've got it passing through 1, -1, -1, and 1, 1. And the next point that I know accurately is going to be 2, 8, somewhere up here. And we've got this turning point here at the origin. So it's going from being this sort of curve to this sort of curve at the origin. Okay, so here I've got three cubic graphs, and we can tell this is the general cubic shape here. And just from looking at these graphs, we can figure out the equations of them. So when you factorize quadratics, that tells you where the quadratic crosses the x-axis. So we can find out the equations of these cubics by looking at where they cross the x-axis as well. And we can write this cubic as a factorized cubic. So here, this one crosses the x-axis at x equals 2, -2, x equals -1, and 1. So we can write this as a factorized cubic. We can say that y is going to equal x plus 2. That's from this -2 root. X plus 2 equals 0 gives you x equals -2. X plus 1, that's from the x equals -1 root. And our final factor is x minus 1, and that's from the x equals +1 root. And if you wanted to, I'm not going to do it here, but you could expand this out, and that would give you your unfactorized cubic. But factorizing cubics is quite hard, so we'll be looking at doing that in C2. For the second one, we've only actually got two roots here. It crosses the x-axis, x equals -1, and it just touches the x-axis here at x equals 2. Now this root here, where it just touches the x-axis, you saw a similar thing with quadratics. With a cubic, we call this a double root, and we can write out the equation of this cubic as y equals x plus 1, that's from our root here at -1, times x minus 2 squared. So this is from this double root at x equals 2. It touches it at the axis, we call it a double root, so it's x minus 2 squared. Our final cubic equation is this one here, and this looks very similar to the graph of y equals x cubed that we just sketched a little bit earlier. And actually, it's y equals x cubed translated to the right. And it turns out that this is actually the graph of y equals x minus 2 cubed. You're going to look at translations in the next video, but we can tell that there's a root at x equals -2. Sorry, a root at x equals 2, so that gives us x minus 2. And that is the only root of this cubic, so it must be cubed to give us a cubic equation here. Now we're going to do the reverse of what we've just done. We're going to sketch a cubic given its factors. We're told a cubic is equal to x times x minus 1 times x minus 2. Now this x here means that our first root is at the point where x equals 0. So let's just mark that on our graph there. This x minus 1 tells us that the next root is going to be where x is equal to 1. So we can mark that on as well. And this final factor, x minus 2, tells us that the next root is going to be at x equals 2. So we can mark that on there, and then we can draw this using our normal cubic shape. So positive cubic, so it's going to follow this shape here, and the graph will look something like this. So when you're given a factorized cubics, you can find the roots of that cubic and do a sketch of it.